Alright, what's up everybody? It's your boy, and I'm here with Homework 4, trying to show you guys how we do the Homework 4. And yeah, so this first page is going to be about trig. We're basically given a bunch of right triangles, and we're to find some combination of missing sides and angles, basically fill in all of the information that we are not given here. So let's go ahead and get to it. I'm going to go ahead and start by marking all of these that have right angles as right angles. I think it'll help me to remember that this is 90 degrees for each of these if I do this. And here we go. So remember, these are all right triangles, all of those are right angles. Okay, so the first one we have 25 and 45. The first thing we can do is, if we know one of the two angles here, we can easily find the second angle, because we know that one triangle has 180 degrees total in it. So we know that this is 90, we know that this is 45, we know that this, we can find this easily by, remembering that the whole triangle has 180 degrees in it. So I'll zoom in a little bit. That's easier to see. There we go. Okay, so let's go ahead and take a look at this. So we have 180 degrees total, minus 90 degrees, minus 45 degrees. And that'll tell us what this angle here is. So 180 minus 90 minus 45 is another 45 degrees. So that's how we can find our missing angle first. Now, for our missing sides, we have the hypotenuse length. We want to find x and y. We can find these easily by finding the x and y components of this. And we do that by taking the sine and cosine of the angle. Cosine goes to the side that touches, so I'm looking at this side. So x is cosine, y is sine. We take sine and cosine of 45 degrees, multiply it by the length of the whole thing, which is 25, and that'll give us the length of our two sides. Now we're going to go to our calculator, we're going to put this in really quick, and it's going to tell us what the dealio is. So let's see, sine of 45 degrees. My calculator's in radians. That's not what I want. Remember, kids, never leave your calculator in radians. Always double check before you do this. This level is pretty bad. So sine of 45 times 25 is 17.7. I'm going to round to one decimal point here, and cosine of that is also 17.7. Now here's why. Here's why the missing sides are 17.7, and they're both the same. It's because this is 45 degrees. Remember, sine and cosine tell us a percentage, or the square root of the percentage, in the x and in the y direction respectively. So at 45 degrees, where it's exactly even, these two are going to come out to being equal. In other words, this is an isosceles triangle. Okay, so over here we've got 22, 15. We want to know our two missing angles and our one missing side. Okay, so the first thing we can do is we can find our missing side. I'm going to do that by using Pythagorean theorem. Notice how we have a and b. We're missing c. I'm going to use a squared plus b squared equals c squared to solve this. So that's going to be 22 squared plus 15 squared equals c squared. My good friend the calculator will tell me 22 squared is going to be 484 plus 15 times 15 is 225 equals c squared. Add that to 484. We get the square root of 709, which is 26.6. So that's our missing side, is 26.6. By the way, these are kind of small. If you're not in a room, just mark it on here somewhere where I can see it, and that's fine. I'm not going to make you try to jam it in here. With our limited space, that should be okay. But anyway, this side's 26.6. That's 709. Take the square root of both sides, and we end up with c equals 26.6. Okay, so now for our two missing angles. We want to find this angle and this angle. I'm going to find this angle first. And remember, we can use, remember the term arc angle. We can use the arc version, or inverse version, of sine, cosine, or tangent to find an angle from sides. I'm going to use arctangent or tangent to the negative first, of opposite side, the side that doesn't touch, over adjacent side, the side that does. So 15 over 22. And that should give me this angle here. It would be pretty funny, wacky, silly, awkward if my calculator didn't actually have arctangent and arccosine on it. Okay, so hold on a minute. I'm gonna go to Google really quick. Sorry about that. It's really awkward that calculator doesn't have it on there. I could have sworn that it would. Give me just a second. Okay, so there we go. Well, this in radians. This in degrees. All right, so arctangent of 15 divided by 22. It's really awkward having to use this calculator, but it's fine. This is going to give us 34.28 degrees. I'm going to call that 34.3. I'm going to double check to make sure this is in degrees, because otherwise I'm going to be really upset. Because otherwise, all right, we're in degrees. We're good. Just double checking. So that's 34.3 degrees is this angle. Now what I want to do is to find this angle. I have options. I could use arctangent again of 22 over 15, the opposite side over the adjacent side. I could do that. If I wanted to, I could do the same thing we did over here, where I go 180 minus 34.3 minus 90 to find this side. I could do either of those. I'm going to go ahead and do tangent again. So tangent to the negative first. This time it's 22 over 15. That'll give me my other angle. So we're going to go second tangent 22 over 15, close parentheses. In degrees, please, not radians. Oh, it's going to be super annoying if I have to manually change it every single time on this. So inverse tangent, excuse me just a second guys, sorry, divided by 15. Dang it, I want this in degrees. Dang it. There we go. And we get 55.7 degrees. And of course, you'll get that if you take 180 minus 90 minus 34.3. These add up to 90 together as well. So if you were to do like 180 minus 90 minus 34.3, you get 55.7 as well. Cool. So that's how we do that part. Now, over here, we have two missing angles and one missing side again. Okay, so we can do this in whatever order we want. I'm going to find the missing side first using Pythagorean theorem. That's A, that's B, that's C. I'm going to say A squared plus B is 11 squared equals 31 squared, or C squared. That gives us A squared plus 11 squared is 121. 31 squared is going to be 961. So we get A squared plus 121 equals 961. Subtract 121 from both sides. we get a squared equals 840. Square root both sides of this, we get a equals 28.9. So this side is 28.9 meters or newtons or whatever the unit here is, although I don't think we were going to units, that's fine. So that's how we do that first part. Now to find our missing two sides, we can use any inverse trig function we like. Let's look at this angle first. So we could do inverse tangent of 11 over 28.9. We could do inverse sine of 11 over 31. We could do inverse cosine of 28.9 over 31. Whichever one you get does not matter. They should all give you about the same thing. There are some issues with rounding where like maybe it'll be half a degree off. It's fine. Okay, so I'm going to do, let's do cosine. So cosine's adjacent over hypotenuse. So it'd be cosine to the negative first of 28.9 over 31. To find this angle, and we can go here, Baba Booey. So it's in degrees. It freaking better be inverse cosine 28.9 divided by 31. All right, and we get 21.2 degrees. Now we can find this angle pretty easily by saying 180 minus 90 minus 21.2 will give us the angle. So this much plus 90, and then 180 minus that. 68.8 degrees. So then this angle up here is 68.8 degrees. So that's how we solve that one. Alright, over here we have the missing angle and two missing sides. We can do this first and foremost. Find the missing angle easiest. We can do that by saying 180 degrees in the whole triangle minus 90 from the right angle minus 15 from this 15 degree will give us the angle of the other side. Pretty easy too. I'm sorry, Tig, I hear you. My cat wants in my room, and he's meowing very sadly. I apologize if you guys can hear. Alright. That makes this 75 degrees. I could have done that in my head. I don't know why I didn't. Please forgive me. So that side 75 degrees. From this, we can get that pretty easily. Now our two missing sides. So we want to find out the hypotenuse, and we want to find out b. This is a little bit tricky because we can't use the Pythagorean theorem because we only have one of our three sides, and we also can't use our vector component splitting method because neither of the one side we have is not the hypotenuse. So this is going to be a little bit trickier, actually. What we're going to have to do is use a good old-fashioned definition of a trig function. So I'm going to start with cosine. So 15 degrees here. We know that the cosine of 15 degrees is going to equal, cosine is adjacent over hypotenuse. So that's going to be equal to 45 over the hypotenuse. I should have marked this with a C, actually, but it's fine. So this mathematically will help us set up to find out what our hypotenuse's length is. So cosine of 15 degrees not in radians, please, dang it. It's gonna be really annoying if it does that every single time. 15. I want it in degrees. Okay, sorry. Cosine of 15 degrees is 0.97. That's going to equal 45 over h. Algebraically, we can get the h over here and multiply both sides by h. We get 0.97 h equals 45. Divide both sides of this by 0.97. And we get 45 over 0.97, which is 46.4. So our hypotenuse here is 46.4. And now that we have our two sides, we could, of course, if we wanted to, do Pythagorean theorem for this side. We could also just as easily, because sine is opposite over hypotenuse, we could say sine of 15 degrees equals opposite the b side over 46.4. So we'll do that really quick. So the sine of this is 0.26 equals b over 46.4. Multiply this by 46.4. So it gets us 46.4. That cancels. This is times 46.4. And we get b equals 12. Almost exactly 12. 12.001. Cool. Alright, so that's how we do that one. Again, guys, the way that we're going to do this, this is just kind of like a review of trig. But each of these numbers that I'm getting, I want to make clear, I'm not showing my calculator on screen, but I'm getting a lot of these numbers from a calculator. So if you wonder where I've gotten a number from, it's usually from a sine or a cosine, a trig function that I'm plugging into my calculator. Okay, over here, so we have missing angle, missing side again. Alright, so let's find the hypotenuse first. That's C. I'll call this one A, it doesn't matter. Again, this is kind of like over here. It's a little bit awkward because we're missing the hypotenuse side, so we're going to have to do the definition of a trig function like we did over here again. However, to find this side is going to be easy, right? Again, it's 180 minus 90 degrees minus 62 degrees, which will give us 38 degrees for this side. Alright, so let's go ahead and find our hypotenuse first. 62 is going to be, that's adjacent, this is hypotenuse, so we can say that the cosine, which is adjacent over hypotenuse, of 62, equals 46, the adjacent side, over hypotenuse. So my calculator tells me that the cosine of 62 degrees is 0.469. I'm going to call that 0.47, equals 46 over c. Multiply both sides of this by c. That cancels out. We get 0.47 c equals 46. Divide both sides of this by 0.47. We get, oopsie, c equals 97.9. So this is 97.9. And then we can find this side using Pythagorean theorem or by doing a trig function again. Let's use Pythagorean theorem this time. So a squared plus b squared equals c squared. That'll give us a squared plus 46 squared equals 97.9 squared. So this much squared this is going to be 9,584. Over here, 46 squared is going to give us 2,106 and 16, excuse me, plus a squared equals. We can subtract 2116 from both sides. And we can then say that a squared equals So sorry, excuse me. Oh, crap. Ugh. I butterfingered my calculator and I gotta type it all over again. Very annoying. Pardon me. Alright, so we get a squared is equal to 7,468. Square root both sides of this, and we end up getting a equals 80 something. Yeah, 86.4. Alright. So that's that. Now, on to the last one. We have missing angle, missing side, missing side. So here are our two sides, 67 and 21. We have a third side, C. We can find the hypotenuse really easily because these two are not the hypotenuse, so we can use Pythagorean theorem for this. That's going to be 21 squared plus 67 squared equals C squared. Let's go ahead and start off by doing that. So 21 squared, boop, is 441 plus 67 squared is 4,489 plus 441. That gives us C squared is equal to 4,930. Square root both sides of this guy, and we get 70.2 equals our C side. Cool. So, got that first. Very nice. Now what we're going to do is we are going to find our two sides. We can find our two sides using any inverse trig function we'd like. Let's find this angle first because I decided to. Now, for this we can do tangent, cosine, or sine to the negative first. Arctangent, arccosine, arcsine. I like to remember this with the term arcangle. You use arc when you're trying to find an angle. I think that's kind of cute and easier to remember. So we're going to use arc trig function in order to find this. We can do any of them that we want. I'm going to use sine. So sine is opposite over hypotenuse. This side is the opposite side. This is the hypotenuse. So we go sine to the negative first of, oops, sorry, not equals. Sine to the negative first of opposite over hypotenuse, 67 over 70.2. Let's go to my annoying calculator that I have up here. So it's going to be, let me double check to make sure it's in degrees. It is, awesome. Okay, so we're going to go second sine of 67 divided by 72, or 70.2, I mean. And we get 72.6 degrees. So this is 72.6 degrees. Now we can easily find this side by saying it's 180 degrees minus 90 from the right angle minus 72.6 degrees. And that'll come out to, I want to say, 27.4. I'm going to put it into my calculator really quick to double check, but I want to make sure. It's 90 minus 72. 17.4, excuse me. Forgot to carry the 1. So that's 17.4 degrees. That means this angle is 17.4 degrees. And we've got it. So that's how you do this first page. It's pretty easy. It's kind of tedious to go through and do all this geometry that you've haven't seen for a while. But this is how you do it. And it's a very important skill to have in physics when we're resolving x and y components. So, great job, everybody. See you next time.